In this video, we're going to take a look at how we go about solving systems a second way, by substitution, by a process called the substitution method. These are the same exact problems which we could have also solved by graphing, but occasionally it's actually easier to use this process of substitution instead of trying to get something like the second equation, 2x plus 3y is equal to 34. Instead of having to turn this into y is equal to negative 2/3 x plus, well, that's really minus 34/3. Instead of having to go through the process of putting that in the form of y equals, this method called substitution allows us to be able to solve without having to kind of go through that hassle. You still need to solve things algebraically, but it's in terms of equations. Instead of rearranging an equation, you're actually going to solve for something. The key part with substitution is to realize the statement that y is equal to 5x plus 2. These are the same exact thing because of this equal sign. So what that tells me is I can do the 2x plus 3y is equal to negative 34. But where this is equal to y, instead of writing a y, what I'm actually able to do is put what it's equal to. Put the fact that it's equal to 5x plus 2. This is what I mean by substituting. Instead of putting a y, I'm going to put what's equal to the y. Substitute that in. And then at this point, I'm able to solve this equation like I've solved the equations in the past. So what that means is that I can take this equation. I have the 2x plus, in this case, I would have to distribute the 3. So 3 times 5 is 15x. 3 times 2 is 6. So it becomes 15x plus 6 is going to equal negative 34. From there, I'm going to add these. I get 17x, okay, plus 6 will equal, and just to make things a little bit easier, I'm going to change this minus 34 to be minus 28 instead, just to make my math a little bit easier. Okay, this is going to be negative 28. Okay, so at this point, I'm able to subtract 6. The 6's will cancel, leave me with 17x. It's going to equal negative 34. Divide by 17, divide by 17, x will end up equaling negative 2. So once I get my negative 2 for an answer, then I need to plug this back in to figure out y, because remember, I always need an x-y combination. So the easiest thing would probably be to plug it back into this equation. So y would equal 5 times negative 2 plus 2. So y would equal negative 10 plus 2, which in this case it would be negative 8. So my solution would be negative 2, negative 8. And then of course I'm able to check that answer. Does what's 2 times negative 2 plus 3 times negative 8 equal? And if it's equal to negative 28, I'm set. So negative 4 plus the negative 24 is going to be negative 28, which is what I had here, so it checks. Okay, let's do another one for an example. Let's suppose I'm given a system of equations where I have, let's do 1 minus 3y is equal to x, and I have 2x plus 5y is equal to 10. So it's not always the first one, but in this case I notice that x is going to be this 1 minus 3y. So then I get the idea that instead of writing this x, I'm going to substitute what x is equal to into that, the second equation. So it becomes 2 times 1 minus 3y plus 5y is equal to 10. I'm going to distribute, so I get 2 minus 6y plus 5y is equal to 10. I can combine like terms. Negative 6y plus 5y becomes minus y, so 2 minus y is equal to 10. I subtract 2. I get negative y is equal to 8, so y will equal negative 8. So I don't know what x is yet, but I know y is going to be negative 8. I'm able to plug this back into the equation. X will equal 1 minus 3 times negative 8. So x will equal 1. These two will, the negatives will cancel, so it becomes 1 plus 24. So x will equal 25. So my solution is 25, negative 8. I can test that by saying what's 2 times 25 plus 5 times negative 8, and does that equal 10? This is 50 plus a negative 40. Does that equal 10? Yes, 10 equals 10, so that is the solution. And that's basically how you solve a system of equation by substitution. I can also check my answer graphically if I were to graph these and find that this would be the point where they would intersect.